Hello students, my name is Gopesh Gaurav. I did my BTech from IIT-JEE and for past 3 years I have been associated as a chemistry expert at askIITians. My today's topic with you guys is chemical equilibrium. In the chemical equilibrium chapter, I have divided it into several topics starting from the basic concepts of equilibrium to the complex concepts of Le-Chatelier principle, and we will be covering this in a systematic manner so that the understanding is very clear to you. Now, let us begin with the basic concepts of equilibrium, where I will be teaching you the difference between physical equilibrium and chemical equilibrium with a more focus on chemical equilibrium. Let us discuss about equilibrium, like what it is and when it is. Okay, when it is an equilibrium. Equilibrium is achieved when you achieve a state in which there is no observable change as the time goes by. Remember, there is no observable change. This doesn't mean that there are no changes. No, there are changes. I mean, the reactant is continuously getting into product stage and the product is continuously getting converted back to the reactant stage. It so happens that the rate at which the forward reaction is going on is same as the rate at which the backward reaction is going on. Therefore, can I say that the rate of the forward and backward reaction are equal? And if this is true, the statement 2 automatically follows. Since the rate of the reaction are equal, the concentration of the reactant and product will be same. No question about that. Okay, fine. Now let us see this video. Okay, this video is of a calcium carbonate molecule. Okay, this calcium carbonate molecule dissociates to give you calcium oxide and carbon dioxide. Okay, now at the same time, these two molecules can also react together and give you back a molecule of calcium carbonate. Okay, therefore this reaction continuously happens. I mean, calcium carbonates continuously breaks into the molecules and the molecules continuously align together to calcium carbonate. Such a condition is known as a case of dynamic equilibrium. It means changes are there continuously but not visible. Now let us remove one molecule of carbon dioxide. Okay, now we have a product, this reactant, so the backward reaction will not happen. Why? Because the reactant of carbon dioxide is removed, so it will not happen. But the forward reaction is going to happen because reactant is still there. So this will again dissociate to CaO and CO2. Okay, now we have the reactant, so a backward reaction will be there. Okay, and now it will again form this and then again back this. So can I say that after some time it will again achieve this 2 arrow, means it will again go into equilibrium. But did you see that it is now a equilibrium with less amount of carbon dioxide, therefore the equilibrium basically readjusted itself. Okay, now let us come and discuss what are the kinds of equilibrium. There are two kinds of equilibrium. One is physical equilibrium and chemical equilibrium. Physical equilibrium, in which no mu substance is formed. It means equilibrium which involves a reaction such that no new substance is formed. It is an equilibrium which involves a reaction in which a new substance is formed. Okay, for example, evaporation. The liquid water will convert into its vapor form, but is a new substance formed? No, initially it was water, finally it was water. Is a new substance formed here? Yes, initially it was dinitrogen tetroxide, now it is nitrogen dioxide. So new substance is formed. However, they have a tendency to revert back to the original state, and the original state has a tendency to revert back to the final state. So is this liquid water on heating goes to gaseous state, which again loses heat or gets cooled to get into the liquid state. So that is the case of physical equilibrium. Okay, this is the example of the same thing, that is water from liquid state is reversing to water into gaseous state. Why we have placed this lid above it? It is done so that the water which leaves this do not leave the system. The system is the part of the universe which is under study. Can I say now, since I have covered it, I am going to study only this part of the universe, so it is my system. So I need it to be covered so that the water molecule in it do not get lost by me. Okay, now let us see the example of chemical reaction. Okay, so it is a chemical reaction or a chemical equilibrium. A chemical reaction or will achieve a chemical equilibrium. Okay, so this orange color is due to the reaction of, but simultaneously there is a fading of this orange color. This is because the reaction is also in the backward direction. Okay, so did you see how different is there? There is a color change in this. Why? Because a new substance was formed. Okay, but this doesn't mean that every chemical reaction is going to have a color change. I picked up this because this was very obvious and could be imaged. Okay, fine. Now look at these three diagram, A, B and C. On the y-axis I am having concentration, see, where the x-axis of all the graphs is going to give me time. Okay, now can you spot something common in between them? Yes, they both, I mean all the three lines, all the three curves, after a particular amount of time, whatever you say, either this or this or this, the curves get linear only after say this time t naught, which is again here also t naught, and here it is this t naught. When the curves get linear, it means that the concentration of this species or the concentration of this species does not change with time. Okay, that means it is at equilibrium. So can I say that it takes same time to reach equilibrium no matter with what concentration you start? For example, this curve A was started with high concentration of NO2 and almost zero concentration of N2O4. Curve B was started with a high concentration of N2O4 and a zero concentration of NO2, means just the opposite of it. And the curve C had a adequate amount of concentration of both NO2 and N2O4. But did you see that at the same time all the three of them achieved equilibrium? So can I conclude that the time required to reach equilibrium, provided that the pressure, temperature and volume are same, is the same? So we have seen about the laws of equilibrium, and the equilibrium is how the equilibrium is achieved and what are the different kinds of equilibrium. I took the example of evaporation to distinguish it from a molecular rearrangement, which was a kind of chemical equilibrium of a physical equilibrium.